Thank you so much for giving me this opportunity to stand in front of you and moderate this panel consisting of very elite panelists. I'm really honored to be here amidst this panel. So this being the last discussion, I do hope that we will be able to closer. Okay, this being the last discussion, I do hope we will be able to evoke a good thing to keep the interest alive. Interestingly, though, the last discussion, if we look at actually the evolution of SDV, what we are all gathered here for the whole day, SDV actually started basically from infotainment and the cockpit experience. That's where it all began, and in fact, it was confined to probably the infotainment for a very, very long time. When we reflect back on the vehicles that used to exist, say 20 years back, 25 years back, practically the SDV was not a known concept, but infotainment did exist, and there was some part of the infotainment which was software driven, which probably users didn't know about it. The second aspect, if you look at it, when we look at it from the user's perspective, what strikes the user the most? The first thing that strikes the user is actually the cockpit experience. How much ever features, wonderful features we might have, at the end of it, how is this experience going to be inside the cockpit? So from that perspective, SDV, I would say, is actually something that is evolved significantly from the way the experience has been built into the cockpit through the infotainment systems and through various other means. So here we are gathered to talk a lot more about it. And to start the discussion, I would like to actually throw an open question to all the panelists here. First, I would like to go with my colleague Basagouda Patil. How is SDV transforming or is being transformed by the cockpit experience?
Hello, good afternoon all. Thanks, Anand sir. Hello. Yeah. Good afternoon all. Thank you for first of all staying on, latching on at the last session of the day. So basically, to the question, right? The cockpit has been at the forefront of electronic evolution in the vehicle. If you look at it, right? So when it comes to SDV, so I want to give you one simple analogy. Like so far, cockpit was, or infotainment, right, is okay. So much of electronics, software, everything was there, but it was it is considered to be a separate issue. So it's like having you have built a house in a plot, okay, and now you want to have more amenities. So in SDV, what happens is, it is going to give you a lot of, processing power, etc. So you are actually kind of moving from an independent house to a penthouse in an apartment with a lot of amenities. Okay, so but you have also need to take care of a lot of compliance as you are living in a community. So it is as simple as that. So if you consider SDV, right, so moving from single ECU into like a very central compute where infotainment could be part of it, it actually gives perspective of like how customers can get more value addition because there is a more compute power, more features can get in, and so for OEMs, how can they be keep what you can say, keep up with the ecosystem which is evolving around SDV. So in that sense, right, so cockpit is quite a key central. It is a driving part of the SDV, and it is going to add a lot more value both to the customer and the OEMs.
Thank you. Over to Rajat. So basically, from an infotainment and connectivity architectures, could you reflect on this point on how SDV is transforming the evolution of the cockpit experience?
So good afternoon, everyone. So I will like to add upon what Basagouda mentioned. If you look at the new zonal architectures that are going to come up with, it is estimated around 30% of the architectures in all of the vehicles by 2032 is going to be so around 30% of the vehicle architecture is going to be zonal by 2032. That's an estimated amount, and predominantly this change would come in the infotainment and the digital cockpit side of things. And why exactly would that happen? So one of the biggest reasons I believe is as more and more autonomy starts coming into the vehicles, the user which is actually inside the vehicle will have now more focus on what's happening inside the car, right? Because now the attention on the road will be less because you have a lot of autonomous features helping you drive the car. So it will be important that you have good experiences inside the vehicle so that you can get the customer buying your vehicle, right? And with the onset of things like SOA and hardware-software decoupling, it will become easier to provide newer features onto the vehicle, thereby leading to newer experiences for the users, right? So this is what I believe how SDVs are going to change the upcoming cockpits of the future.
Thank you for that, Rajat. Now, can I request your views, Kannan, Varadhan, based on your experience on augmented reality and heads-up displays? How is this evolution of SDV transforming those aspects?
Okay, good afternoon, everyone. So when it comes to head-up displays, the concept where we have in production in vehicles today are pretty much simple head-up displays, and there are few systems that are already in production that can do some level of augmented reality. But there is a huge challenge with respect to bringing in augmented reality head-up displays into mainstream, mainly because of constraints related to packaging and constraints related to thermal management, right? Constraints related to optics. So head-up displays, and especially augmented reality, the technology is still evolving. Whatever we have today, in terms of dual mirror-based head-up displays can achieve only partially the augmented reality use cases that we want to put in our cars today. And there are newer technologies that are evolving, like waveguide technology, holographic technologies, right? So these things are still shaping up. The biggest challenge we have there is how do we manage the optics, because you have to project the AR display in the field of view of the driver at a distance 20 to 100 meters far, and this is okay in night driving conditions, but when you have sun load, right, so you really need quite a lot of backlight in the order of greater than 15,000 nits, and this is causing further challenges in terms of thermal. When you are putting such high brightness backlight, how do you manage the thermals, because the head-up display itself is packaged inside the dashboard, and how do you manage the thermal, right? So that is another challenge. And then of course I talked about the volume related challenge. Today's head-up displays, dual mirror based systems require a huge volume to be packaged. If you want to do augmented reality, you at least need 15 to 20 liters of volume to be packed in the dashboard, and which is not very practical for all the cars because you have several systems, running beneath the dash, right? Things like your HVAC, there is cross car beam, there are electronics, our infotainment system, silver box itself is in the dash. So there are so many items already packaged, and there is a huge real estate crunch inside the dash. So packaging is the biggest challenge. So it is a convergence of multiple disciplines, the mechanical design, packaging, optics design, thermal management, and finally, the software aspects where we have to do a lot of sensor fusion, manage latencies, do some prediction related stuff to put things in the scene, right? So because whatever you want to put in the field of view of the driver, should be useful and distraction free. At the same time, you should not have latencies. What you see in front of you already, you cannot embed an AR object after you see, right? It doesn't make any sense at all. So latency management is critical, and all those other challenges I spoke about in terms of mechanical optics, and the thermal management are key to making this technology mainstream in the near future. So today we already have systems in place, but the technology is evolving, and very soon, in the next 2 to 3 years time frame, you will see very, very capable, sophisticated augmented reality systems in production. So by 28 to 29 time frame is what we are targeting today.
Yeah, thank you. So as per your things, basically packaging of these kind of features is going to become more of a challenge going forward. Thank you. Now moving on to NandaKumar, I'm going to pose 2 questions to you. Now we have all been talking about SDV. Okay, what in your perspective or your understanding of SDV, because SDV has so many flavors, so many people give different definitions to SDV. So what is it in your, from your perspective, what do you call SDV? That's the first one. And secondly, one of the most significant challenge today is that there are plenty of applications that now runs in the car which are all SDV driven. Now we need, some of these applications need to be isolated. Otherwise there could be a conflict, there could be certain interference. Now how can we actually use the concept of containerization or virtualization using hypervisors? How can that help us transform this SDV experience in a significant way?
Good afternoon, everyone. I think since morning everyone is here and you heard almost everything, every buzzword in automotive industry. You heard about new END architectures. You heard about zonal computers. You heard about high performance computers. You have heard about peripheral nodes. You heard about DevOps. You heard about OTA. You heard about ADAS. You heard about electrification. I think everything what is there in automotive industry almost you heard since morning. I hope by now you have a more confusion. What is SDV? How many of you are having that confusion? At least I see few hands raised that I came here to understand what is SDV, but I learned everything what is there in the automotive industry. That's what everywhere I go, any automotive event, the most talked topic is software defined vehicle, and towards the end of that event I am also confused what is SDV. So we at Elektrobit thought that we should give some shape and form to what is software defined vehicle, and we from the industry first we come up with a software defined vehicles maturity model, where this maturity model talks about level 0 to level 5. So let me take few minutes to explain what is level 0 and level 5. So it's not that we are talking about the software for first time, right? We have electronic control vehicles units in the vehicle since decades. If there is electronics, we need software to control that electronics, which means software was there in the vehicle since long time. So we call level 0 as software enabled. So just for you to make understand what is software enabled, the mechanical functions were controlled through the software. To quote a simple example, we had in two-wheelers the carburetor system is now replaced with EFI, which is electronic fuel injection. which means software is controlling the injection. That's what we call it as level 0. The mechanical functions are made possible to control through the software, which is level 0. Level 1 of the SDV is what we call connected and connected. Through connectivity, for example, if you are buying any car today, you have the mobile app and you can connect to the vehicle and you can monitor the fleet of diagnostic data or some information related to the vehicle. And also you can control few functions like locking, unlocking of the vehicle. So which means you have the connectivity established and also you can perform few operations towards the vehicle. That's what we call level 1, which is connected. Level 2 is more of software update. When you purchase the vehicle, OEMs are offering you a set of features when you purchase the vehicle even today. And OEMs takes the responsibility to make sure that these features are made available throughout the vehicle life cycle. That means OEMs are responsible to maintain these features. So level 3 is updatable, which means you are getting the software updates over there, which is maybe for the fixed feature set which is available inside the vehicle at the time of purchase. Level 4 is the upgradable, where you have the option to increase the feature set after you post purchase of the vehicle. It could be related to personalization of your vehicle. It could be a new features which you are adding like eco and sports mode, or maybe you are adding seat heating functionality in the winter season, or you can call some subscribed features which what we call it as upgradable, which is level 3. And level 4 is called what we call it as a software platform. And basically if you look at iOS, Apple doesn't maintain the multiple operating systems, right? Apple have always the one latest and greatest operating system running in all the iPhones, which they have the backward compatibility, and also maybe in some cases they think of forward compatibility, and they will have the one latest version which they clearly state that this OS can run on which version of the iPhone. So if you are able to create such a software platform for your vehicle control, electronic control units inside your vehicle, which is then we can call it as a level 4. And the last and final one is the level 5, which we call it as an innovation platform. Basically where you are so far the tier ones or the OEMs are the ones who is developing these applications and making these applications part of the use. But level 5 talks about innovation and opening up the innovation platform for the ecosystem, where the third party developers can develop the apps and push these apps to the vehicle. That is when we can call it as a level 5 software defined vehicle. So it starts with level 0 where software enabled to the level 5 where is an innovation platform. So coming to the second part of the question, basically as on today, if you look at most of the vehicles which is running on the road, all of the vehicles are coming with level 2 and some of them is coming with level 3. Basically level 2 is updatable, level 3 is upgradable. But there are only few tier 1s or OEMs who is thinking and started developments in the area of level 4, which is software platform. But many of the OEMs which are already hit the road is with the level 5 is for the cockpit domain. So basically cockpit is the only place where you see a lot of software defined features are already made available, and also you can see there are a lot of third party applications which are being built, which is based on Android, and these applications are being pushed to the vehicles. So that's why I would say in short, software cockpit is the proof point for the software defined vehicles, and also it is going to accelerate the journey of software defined vehicles.
Thank you. Wonderful explanation on the 5 levels. I really like that way you have categorized that into levels. I think you have also set the platform for my next question, the next round, to Basagouda Patil. So basically NandaKumar talked about the Android kind of a thing where the third parties can develop apps. Now, I mean, many of us are used to this concept of Android Auto that is there. What is exactly the difference between Android Automotive OS different from Android Auto? What's your view on that?
Hello. So basically, Android Auto is there pretty much, on many of the vehicles. So as per, recent Google I/O 2025, right? Every yearly conference hosted by Google. So there are around 250 million vehicles with Android Auto. Android Auto is basically a projection technology from Android for Android phones from Google on Android phones. So wherein you can have a designated apps projected onto your screen. So the app ecosystem is built in such a way that you can develop apps which are only for mobile or which are compatible with the CarPlay as well. So there is a lot of encouragement that how many from Google, they are making it quite open to develop apps for the car because now everything is getting connected. Whereas now coming to the Android AOS, right, automotive operating system. So basically here Google will provide the full framework of Android onto the vehicle. So you don't need to have a phone as such to use the Android features. So basically, it is not a parallel development branch from Google. It is the same variant that get extracted from the normal AOSP, mobile platform. And you can imagine instead of normal other services which are there on the phone, so you'll have a car service, a car manager, or a car application. So those kind of framework is built, and then when you have a hardware abstraction layer at the lower layer, right? So you will have similarly as a vehicle, it's called VAL, vehicle hardware abstraction layer. So basically, OEMs along with the tier ones or other service providers basically take a a release from AOS, which is usually one version whose release is one version below than the normal AOS release, standardized, and then you basically start building up your features across at the lower platform and start developing your applications. So again, in deployment, so this AOS, right? So it is just not that you will get entire phone onto your car. It's not like that. So if you want to do that, you need to go through something like Google Automotive Services, where there is a contract between OEM and the Google, where you need to comply with a lot of things, in terms of compatibility, safety, security, driver distraction, etc. So it is quite defined by Google. And there are some vehicles on this who have adapted to the gas, but there are a lot of OEMs who basically don't get into gas, which is optional contract, and they use the this AOS framework, and they engage into other third-party app developers. Like if you don't want to go with a Google Map, you engage with some other standard maps, and then you integrate. So basically, this as per the Google I/O, there are around 50 models of cars with this native Android on the vehicles available. So it's quite evolving since few years, and and it is there are many hardware the SoC suppliers as well, right? Majorly Samsung, Qualcomm, and here MediaTek are all offering solutions that stack platform based on Android. So this is where we are. So you basically don't need the mobile phone to use it, and there is a flexible platform available for the OEMs.
Yeah, thank you. That's a very interesting perspective on Android Automotive OS. So really look forward to that becoming more popular, and so that it replaces the Android Auto that we have. Now, actually talking about the virtualization, the hypervisor, and then the OS, the next question that pops up is basically that with the rising intelligence of the cockpit, how is the service-oriented architecture seen as an enabler for, with all the modularity and flexibility that we really want to move towards? Rajat, can I ask you put that question to you?
Hello. So before we go into how SOA is acting as an enabler, let's look at how the existing or yesterday's automotive software was being made. Predominantly signal-oriented architecture, where basically you used to have signals that were being sent at some rasters, application running at some rasters, and all this was scheduled inside an RTOS scheduler combined with your basic software services, and then all this put together in the form of one final executable. Now, what this led to was that this software, if required to be updated, your car had to be brought either to a service center or to a designated place, and then only you could update the software. However, with SOA, this thing changes. Now, in SOA, basically, you would be able to create components or services where the information gets exchanged in the form of messages. And this basically leads to that each service can now be created as an application by itself, which is dynamic in its own form and disconnected from the rest of the software services. It's only talking through the interfaces that are defined in my middleware. And because of this, what one can do now is perform OTAs and update these applications or services that are running on my HPCs. Now, how does tool makers like MathWorks come in and help people make these services? So we have a three-pronged approach that we typically recommend with anyone that we are working with. We say that you start with the concept phase where you design these services, make sure that the algorithm that you're trying to design is working as per the requirements. Now, once that is done, make sure that you are then at the second level applying the correct interfaces, how this needs to talk to your middleware and rest of the services that are there on the HPC. Finally, the third approach is we allow you now to generate production-ready code out of these services that you have created. Now, these production-ready code could be either deployed onto something like an adaptive AutoSAR stack, or could be some third-party stack, or even for that matter, Android. In fact, Renault is actually deploying these. So, in fact, Renault is already creating these services inside Simulink for that matter, and generating production code that they're then going on and putting on Android. And not just, it doesn't end just with Renault and some of the European players, it's even now happening in India. Most of you might have seen the latest Mahindra releases, the P6 and the XC9. They come up with these fancy very fancy feature called as GrooveMe, where you can synchronize the music and the interior as well as the tail lights of your car to the music. And then you can actually create a discotheque inside your car. Now, this entire application has been created inside the Simulink platform, where they conceptualized the application first and then tested it that they could actually control the light by using some of the ad hoc testing methods. And finally, then they generated adaptive code out of it, and which they went on to integrate with the rest of their software stack. So, in short, SOA is an enabler in the form it will allow OTA and it will allow hardware-software decoupling. And tool makers like ourselves at MathWorks, we have this approach, like I mentioned, of conceptualize, test, and then generate code for production is the way how we are helping the industry to make these services. Yeah.
Thank you for that, Rajat. So, over to you, NandaKumar. So, what benefits do OEM gain by using hypervisors in cockpit domain controllers compared to the traditional ECU-based kind of a system?
Yeah. Before I start with what are the benefits, if you look at, I consider for the software-defined vehicle, E&D architecture as a backbone. So where E&D architectures coming with central high-performance computing, followed by the zonals and then the peripheral nodes. So which provides us the computing power, connectivity, and also the seamless communication between the nodes. So it all depends on how, in order to consolidate the number of ECUs, it is very much important to understand at the system level how we are going to consolidate different ECUs into one high performance computer. Take the example of Cockpit. Today, where we are doing the developments, the Cockpit is integrating the instrument cluster, infotainment, and also the heads-up displays, rear seat entertainment, and also some of the level 0 ADAS features where the driver alert functions which are being integrated into the cockpit systems. If you look at all this integration of different ECUs, also there is a different time critical applications for instrument cluster and also safety relevant applications as part of this instrument cluster and ADAS. So even though we have the computing power available at the hardware level, we need to think of an architecture which will enable us to bring in all these different safety and security relevant functions onto one chip, and also the necessity of how to isolate them and then bring in a modularity and also scalability without compromising on the safety and security. That is the key for any of the HPCs to become successful, which will be then the backbone for the SDVs to succeed. So here is what actually, if you look at any of the SOCs today which is being used for the cockpit development, it comes with the traditional microcontrollers which are being loaded with the real-time operating systems and the middleware stacks which is of classic AutoSAR, then which can be used to develop the time critical and safety critical applications. And on the processor side, actually we have the hypervisors where we will bring in the hypervisors and create a virtual machines inside the HPC wherein you can host the different operating systems. On the single SOC, now you have the real-time operating system running on the microcontroller and Android running for the infotainment, and also the QNX or the Linux which is running for the instrument cluster related application. So it is, how is it going to help the OEMs? Coming to that question, basically you are bringing now all the functions together onto one chipset. You can avoid the latencies, the communication between the different nodes. If you take in the traditional vehicle, you used to have for instrument cluster one electronic control unit, you used to have heads-up display, one control unit, and then you have the infotainment, one control unit, and the rear seat entertainment, one control unit, and the ADAS related one control unit. Now you are integrating the functions which are distributed across 5 different ECUs into one, which means you are going to save a lot of wiring harness related costs, and also you are going to avoid the latencies of communication between these nodes. If some of you are familiar, Android takes its own time to boot up to 10 seconds, wherein QNX can come in 1 second, and then the middleware related to the QNX can be loaded in up to 5 seconds, wherein on the real time you have the system up and running in milliseconds. So therefore the HPC is going to provide you these different boot times. Then you need to decide applications on which applications to run on where and how to ensure that there are safety relevant stuff which is not compromised. So that's what the advantages we get by integrating the different functions. HPCs enable that flexibility, wherein OEMs can save the cost, bill of material of electronics, and also avoid the latencies. And also the modularity with hypervisors, it is easy to maintain the softwares. So everybody talking since morning the VOTA, and even in the vehicle you have 100 ECUs, it's not possible to update all the 100 ECUs every time. It is very important in your E&D architecture at the time of the vehicle design aspects you have to consider. What are the VOTA, what ECUs will need VOTA updates on what frequency. For example, HPCs might need VOTA updates at a frequency of weekly, wherein zonal might need at the frequency of monthly, wherein the peripheral node may not need, some of the nodes may not need any updates, some of them may need yearly or as and when there is a safety or security related patches required. So it is very important for us to consider all these aspects. Nothing comes at the free of cost. VOTA is also cost to us. So I would say there are a lot of benefits for the OEMs. OEMs are, according to me, the software defined vehicle is going to drive a lot of benefits to OEMs and also provide a lot of value added features to the end customers, wherein they can personalize and keep the car refreshed up to date every time. I see the benefits both on the OEM as well as on the end consumer side. So with this, I am very much confident that cockpits are the ones which is going to give that experience to the end users, where you can touch and feel. So recently I was talking to one of the OEM. They said, we talk about a lot of E&D architectures, but the end user, when they visit the showroom, they don't care about whether you are using the zonal computer or HPC or whether you use the round cable or the flat cable of wiring. it doesn't matter for them. When they get into the car, how is the look and feel, and what is the experience which that the end user is going to get? That's what matters. Which means, if you look at last 2-3 years, the experience inside the cabin has changed. The cockpits has become more and more bigger, and also more and more digital and more interactive based. So I would expect by 2030, the humans will be interacting with the machines inside the car that will be with the cockpit systems.
Yep, thank you. So you have led me on to the next question, probably the final question here before we close this session. So basically, just NandaKumar just pointed out there how the cockpit is transforming with a lot and more. The focus is shifting more on the customer experience, the cockpit experience. Now, with augmented reality and heads-up displays, how does it help the driver in creating a better awareness for the driver, so that the alertness or whatever the situation, and he gets a better from a safety perspective also, and the driving ability, all these things can be impacted.
Okay, so I talked about all the challenges with respect to augmented reality, but this is a technology that is pretty much required in today's world, mainly because AR and head-up display is all about situational awareness, right? So you don't want to distract the driver, when the driver is going on a long trip, especially when the driver is fatigued because of long distance driving. So you try to put things in the field of view of the driver, so that the driver doesn't have to look at the head-on display, meaning the displays that you see on the cockpit, right? All those LCD displays. So if you look at some statistics, right? So if you take statistics from the US Transport Department or the World Health Organization, a lot of accidents, are happening mainly because of driver distraction. So in fact, in terms of percentage classification, more than 80% of accidents are categorized because of driver distraction only, right? And part of the driver distraction is also contributed, because of the limitations we have in terms of providing content to the driver, right, in a timely manner, in a very convenient form, right? So whatever you put on the displays, the center infotainment display or the instrument cluster display, over a period of time, when the driver has to switch between the near display versus the real scene in front of the driver, it is causing a lot of distraction, right? So the augmented reality head-up display is intended to bridge that gap. How do we bring in situational awareness? How do we make sure the driver is focused on the road, on the scene in front, right? So that you don't need to look at the instrument cluster display or the infotainment display frequently. So you put content there, only the necessary, useful and critical content in front of the driver, and you also make sure that the content captures the attention of the driver, at the same time does not distract the driver, right? So there is a lot of user experience, UX related design that is happening in the area of augmented reality as to how do we capture the attention of the driver. Especially, there is a phenomenon called inattentional blindness, right? If you're driving for more than 4 hours, 5 hours, though you are focusing on the road, you tend to miss things that are going on in the scene in front of you, right? Someone is crossing the road, because of fatigue, sometimes you tend to miss, and this results in accidents. So if you want to overcome this inattentional blindness, you have to create UX in such a way that it captures the attention of the driver, right? So whatever you put in front of the driver as augmented reality, it alerts the driver in a way that the driver takes cognizance of the situation, is able to react immediately and avoid situations, right? So that is one aspect of bringing in augmented reality. And there is also another aspect of augmented reality where it is more to do with convenience. Say all the navigation related integration on the AR HUD. So you see your turn by turn instructions right on the road in front of you. The right turn or left turn arrows are appearing exactly at the junction where you have to take a turn, and then your point of interest, it just keeps popping up. Point of interest just at the exact location. It marks a building and then says this is where you have to go. So there is a lot of convenience features as well that are being built into augmented reality. But the most the primary function or purpose of AR is to bring in the situational awareness, make the driver react to situations quickly, and avoid accidents.
Thank you. So thank you very much. That really brings us to the end of this session. Just to summarize some of the key discussions that happened, as much as software is enabling a lot of features, a lot of things, it also brings in a lot more compliance requirements. So customers get more features, while the vendors, it also offers the vendors to create the ecosystem that is required. With a lot of attention required, taken away, the driver is now actually able to free up this because of all the assist that he has. The experience shifts more to the cockpit experience. So even how the driver is going to feel, how comfortable he can feel. So that is another aspect of how the SDV is enabling all this shift. And with all these things, we need to package everything in a vehicle, the given space, where the space is actually going to be on one side. The space is definitely going to be reducing. We need to be not compromising, but then we want to optimize the space. So there is a lot of packaging that is required, which is actually going to be a challenge. So this is with this, I would like to conclude the discussion, and I really thank my fellow panelists for sharing their expertise and sharing their views. It was a wonderful session. Thank you very much, and I hope you all enjoyed this session. Over to you now for any questions. We can just take 2 questions max. Questions?
Maybe we have to ask a question, right? What is SDV?
Thank you then. Thanks a lot for this opportunity to be here. Thank you very much.